Okay, in this video, we're going to be learning how to find the percent composition of a compound. In order to do this, you do need a calculator. It does not have to be a graphing calculator, a scientific calculator, the calculator on your phone. Any kind of calculator will work just fine for this. You will also need a periodic table because you need to look at the masses of each element in the compound. So remember, on the periodic table we use in class, the mass is this bottom number. Remember, the top number in each box is the atomic number. We want the mass numbers. So percent composition is simply the percent by mass of each element in a compound. And to find the percent composition, we take the mass of the element divided by the mass of the compound and then times 100 because we want it as a percentage. So let's look at one together. So if I want to find the percent composition of nickel 2 bromide, the first thing we're going to have to do is find the molar mass of nickel 2 bromide. And we've done this in class before, but it's been a bit, so we'll review it. So if I look nickel 2 bromide, it's going to be NiBr2. And that's from our nomenclature. If you need to go review the rules, that would be rule 3. So the first thing to do is find the molar mass of nickel 2 bromide. So if I look at the periodic table, I'm going to find the mass of nickel. And it is 58.69 grams per mole. And then I'm going to multiply by 1 because there's only one nickel in the compound. I'm going to repeat that process for bromine. So the mass of bromine is 79.90 grams per mole. This time I'm going to multiply by 2 because there are 2 bromines in the compound. So that's 159.8 grams per mole. And to find the molar mass of the entire compound, we're just going to add those up. So 58.69 plus 159.8. That gives us 218.49 grams per mole. And again, that's the molar mass of the whole compound. That is our first step every time. We need the molar mass of the entire compound. From there, to find the percentage of each element, we're going to take the mass of the element divided by the mass of the compound times 100. So if I want to do the percent of nickel in nickel 2 bromide, I'm going to take the mass of the element, 58.69, divided by the mass of the compound, 218.49, and then multiply by 100 because it is a percentage. And for these, you round to just a couple decimal places. It'll be just fine. So that gives us 26.86%. To find the percentage bromine, again, the mass of the element, which we found was 159.8 grams per mole, divided by the mass of the entire compound, so 218.49 grams per mole, times 100 because it's a percent. And we get 73.14%. Now, the really nice thing about these is that you can kind of check that you did what you needed to do. If this is everything in the compound, then the percentages should add up to 100. And in this case, they do. Now, on occasion, they may be off by just a little bit because we did round, but it should still be very, very close to 100% because that's everything in the compound and everything should be 100%. Let's do another one. So if I want to find the percent composition of barium perchlorate, that's going to follow rule 1 if you need to review your nomenclature. But barium perchlorate is BaClO4 2. So again, the first thing we're going to have to do any kind of percent composition problem is to find the molar mass. So you're going to look at your periodic table. First thing we're going to find is barium. Barium has a mass of 137.3. There's only one barium in the compound, so times 1. So barium in the compound is 137.3 grams per mole. Next, we look at chlorine. Chlorine on the periodic table has a mass of 35.45 grams per mole. And you have to be careful anytime you have your polyatomic ions. There's only one chlorine in the polyatomic ion, but there are 2 of that ion altogether. So 1 times 2 tells me there are 2 chlorines altogether. So that gives us a mass of 70.90 grams per mole. And finally, for our oxygen, oxygen has a mass of 16.00 grams per mole. There are 4 oxygens in the ion, but there are 2 ions in the compound. So 4 times 2 tells me there are 8 oxygens altogether. That gives us a total of 128 grams per mole. Again, to find the molar mass, we're going to add all of this up. We get 336.2 grams per mole. Now that we have the molar mass of the compound, we can find the percent composition of each element. So to find the percent of barium, we're going to do the mass of barium divided by the mass of the entire compound times 100. And we get 40.84%. Do the same thing for chlorine. My paper up a little bit. So percent of chlorine, we're going to do the mass of chlorine, so 70.90 grams per mole, divided by the mass of the entire compound, 336.2 grams per mole, times 100 because it's a percent. And we get 21.09%. Finally, for the percent of oxygen, we're going to do the mass of the oxygen from the compound, so 128.00, divided by the mass of the entire compound, 336.2, times 100 because it's a percent. And we get 38.07. And again, you can check those. They should add up to very, very, very close to 100. Again, maybe a little bit off because we rounded, but this one does in fact add up to exactly 100. So the percent composition of barium chlorate breaks down to 40.84% barium, 21.09% chlorine, and 38.07% oxygen. That's for the percent composition of the entire compound. If it asks for just one thing, you'd still find the molar mass of the whole thing. But if it asks for just percent of barium, you would just do this part. You wouldn't have to do the other two. Hope that makes sense. As always, if you have questions, you can text me, you can email me. Let me know if you need help.